Hello, class of Sandra Cisternos. That's how you pronounce it, right? I'm sure that's how you pronounce it. This is yours truly, Gabriel Ramirez, back at it again with a YouTube video. This is embarrassing. Okay, so today I made an 8-1 factors and greatest common factor slide. I made this early so I can give some of y'all a few, not pointers, but you can just copy out. No, don't copy out from my example. Don't copy. Just like use my video, I guess, as a guideline. And if you don't know what to do, I made this as simple as possible. I didn't show my face. I don't have any editing program. This is just my MacBook and me and my phone. You'll see that soon enough. Okay, so let's get started. 8-1 factors and greatest common factors by Gabriel Ramirez. Well, I said that already. Okay, introduction. In this lesson, we will cover up on the basics of finding the factors, prime factors, greatest common factors, GCF, which I will be referring it from now on, and greatest common factors of monomials. These skills build a proper foundation for further algebraic concepts and skills. Things like 8-2 and so on and so forth. Okay. Finding the factors of numbers. This is the really basic skill. I just decided to put it here just in case y'all forgot this. So factoring is used to find all the numbers that are used to multiply to get the product of x. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. I found this. As shown, these factors can be multiplied by another factor to get the product of 12. So, as shown in this beautifully displayed picture, 1 times 12 is 12, 2 times 6 is 12, and 3 times 4 is 12. Like show here. Wow! Hopefully you knew this. That's why I put wow. Writing prime factorization. Okay. This is a skill that is displayed in this lesson. Prime factorization simply all the factors of a number that are prime. A prime number is a number that only has two factors in total, 1 and itself. For example, the number 5 is a prime number. The factors of 5 are 1 and 5. Okay, so if you didn't understand that, then just look at these two methods of prime factorization. So the first method is a factor tree, which is the simplest, or not the simplest, just it's a factor tree. Okay, so in order to use this, it kind of looks like a tree if you go down. A Christmas tree kind of looks like it. So you put the original number on top, and you slowly build it down. So by the factors, so you would do 6 times 10 is 60. Now 2 times 3 is 6, and 5 times 2 is 10. So you get the point. And and you keep doing that until you only get prime numbers. So 2 is a prime number, 3 is a prime number, 5 is a prime number, and 2 is a prime number too. Okay, boom. Ladder diagram. This is the second method, and hopefully this looks familiar to you guys, just hopefully. So in this method, you just keep dividing, like I say, by a prime number. Now, the number that goes here has to be a prime number, or else the method just won't work, okay? That's like the most important note to put here. This has to be a prime number, 2, 3, 5, 7, 11, things along those lines. And so you keep dividing, or however you want to call it, by a prime number until you get a number that cannot be divided anymore. Okay? So 2, 2, 2, and 3 are prime factors, you would say. Okay? And slide number 3. Finding the greatest common factor of numbers. Okay, so factors that are shared by 2 or more whole numbers are called common factors. The greatest of these factors are called the greatest common factor. Whoa! Simple. Okay, put simply, the GCF of 2 numbers are the greatest factors that can be used to multiply into the original numbers. Grammar. Okay. There are 2 methods of finding the greatest common factors. So, hopefully this method is simple enough. It's probably it's the easiest to understand. So you list all the factors, and look at these circles. They're not placed right. Oh well. And you list all the factors of the 2 numbers, and you circle the greatest common factor. So in this case, the greatest common factor is 12, as shown here. And then the second method is to use prime factorization, as shown in the last slide, which you have to make the ladders and everything. So once you make the ladders, you can write it down. The prime factorization of 18 is 2 times 3 times 3. The prime factorization is 27 is 3 times 3 times 3. So you combine these in order to find the greatest common factor. You combine the two greatest common factors and you multiply them. So the GCF of 18 and 27 is 9. Hopefully you understand this. Just get a good look if you want to take notes or something. Or you can just pause the video. Okay, next slide. Bam. Finding the GCF of monomials. Yeah. One can also find the greatest common factor of a pair of monomials. The easiest method to solve is by using prime factorization. So, as you noted, there's nothing on this slide. And you will see very soon. Just not now, though. Just keep waiting. Not now. Not yet. Not yet. And wait a moment. Nope, not yet. Not yet. Now. Oh, hello. We have switched back to my phone, and we will be doing prime factorization using monomials. That is a monomial, and 6x squared is a monomial. So we're gonna do prime factorization, and we're gonna find the prime factorization of monomials. So there are two methods. Well, basically the easiest method to find a prime factorization in monomials is to use the ladder method, and this was described in earlier slides. So, well, let's jump right into this. Okay, so part of the ladder method is to just rewrite the problem, 3x squared and 6x squared, then put like this little ladder looking thing, which is why it's called the ladder method. So what you do in prime factorization is you have to find all the prime factors of these two numbers. So in order to get that, you have to put a number on this side of this little ladder thing that has to be prime. And slowly, once you multiply all of them together, that's a prime factorization. And once you put a number, you have to put a prime number here that can multiply, that can be divided by these two numbers. So the first number I would put would be 3. 3x squared is divided by 3 is x, and 6x squared divided by 3 is 2x squared, and never x squared. There you go. And then a number that can be divided to both of these is x. So we're just going to do this again. Bam. Divided by x. Takes away that first exponent, x or x1, same thing. And just 2x. And then you can divide this by x again. So now it's just 1 and 2. So prime factorization is all of this. Oh, focus. There you go. And then once you combine all of them together, you'd get 3 times x, and that equals 3x squared. So the prime factorization of 6x squared and 3x squared is 3x squared. Simple, right? Thank you, and subscribe. Hopefully you enjoy this new video. It's 8:34 p.m. Nice.